To all 𝐸nCon managers and ESG champions out there, greetings from Raghavan, Overpack Systems, Chakan, Pune. I have 38 plus years air conditioning refrigeration industry experience. I manufacture industrial hot water heat pumps and customized process chillers. Through this video series on heat pumps, I am trying to share whatever I have learned by looking at different industrial heat pump applications with all of you. I hope this will help you, at least in some manner, to evaluate projects that are available in your workplace and to suitably take it up for implementation. In the last episode, we discussed how we could use the cold air coming out of heat pump just to improve the value being provided by the heat pump. So one of the questions I continuously encounter when I visit the industries for heat pump is, can it simultaneously generate chilled water for us? Answer is yes. So if we take water to water heat pump, automatically we can generate chilled water on one side and hot water on the other side. Now looking at industrial applications, I generally see two types of opportunities for the generated chilled water. One is for process cooling applications, like in your typical shop floor, there are so many hydraulic oil cooling units, coolant coolers, induction hardening chillers, laser welding machine coolers, etc. Now the chilled water generated from the heat pump could be used for some of these applications. The second opportunity I see in industries existing for the chilled water generated is for thermal comfort air conditioning system. Now first we will discuss about both of these type of applications. Let us start with the process chiller application. So in process chilling, normally in industries in your workplace, for all these applications that I described, you don't require very low temperature. Oil cooler maybe has to maintain a hydraulic oil temperature of almost ambient, 30, 35, 40, not more than that. Induction hardening chiller, about 25 degrees, 30 degrees is what you want to maintain. So generally these are slightly on the higher side. So we can, using this heat pump, we can generate as low a water temperature as 10 degrees centigrade, that is possible. While generating 80 degrees centigrade water or 120 degrees centigrade water on the condenser side from a heat pump, we can generate as low as 10 degrees centigrade chilled water temperature. User settable, you may very well increase it to 15-20 as you need. So this is a very good application. Now some of the practical implications that I want you to brief about. So please keep this in mind so that you will be able to evaluate your projects appropriately. Number one, the chilled water will be available only when the heating system is on. For example, your heating demand is fulfilled. The whatever thermal storage tank is there, that is also has reached the set point temperature, let us say 80 or whatever, 115, 120. The whole system will go off because the temperature sensor is on the hot water side. During that time, when it goes off or when it modulates, assuming it is a modulating compressor, the chilled water generation will be impacted. It will not be the same capacity, either the capacity will be less or it may very well go off if the compressor is of on-off type. So this is one thing we have to keep in mind. So usually this requires a discussion between you where we want to understand the entire scope of which all process systems have to be cooled, what is the temperature required, what is the tonnage capacity required, etc. And then we try to align it with the heat pump selection. So if we align it appropriately, there will be some standby provisions. The way we select the heat pump compressors, heat pumps are also made in modules. It is available in different capacity compressors. There are approximately some 6 models of water heating scrolls that are available. So using these compressors, we can build very huge systems also. So there will be multiple compressors mostly used in higher capacity heat pumps. So by trying to match the chilled water requirement with the number of compressor selection, we usually will be able to figure out what is an optimum design point so that the chilled water will be available. So this is one. Second, you can always complement whatever is the shortfall of chilled water with something else. Now mostly all these heat pumps currently we are talking about, most of these heat pumps go for retrofit applications. New systems are also there wherever new plants are being set up, but percentage wise that is less, and we are discussing more about the retrofit opportunities. If it is retrofit opportunity, your industrial processes are already established with already existing chillers, right? So one more opportunity I see is whenever I visit the shop floors, I see like multiple numbers of smaller capacity chillers being used for cooling hydraulic oil, for example, or many other such requirements. So instead of using so many small units, for example, 40 numbers of 1 ton or 2 ton capacity chillers individually on a standalone basis catering to the demand, we can very well go for central chilling unit. Wherever we are falling short or wherever we have a doubt when the heating system goes off, the chilled water capacity may go down, we can always complement it by putting a standalone chiller to take care of this requirement. So this is very much possible to do, and it definitely improves the ROI and make the heat pump a very good project for you to take up. Now this is about the process chilling. Now let us move. Before we talk about the thermal comfort HVAC chilled water requirement, there is one thing I want to remind you. Assuming the chilled water capacity demand is met by the heat pump, but heating demand is still required, it is there, it has to run, but chilled water side demand is met. How the system will behave? So for this, whenever we are talking about water to water heat pump systems, from my experience, unless we match it so accurately, which is not practically possible, most of these water to water systems have to end up as a hybrid heat pump. So whenever the chilled water demand is met, for example, the water temperature, you require 15 degree chilled water, it is continuously dropping, we have reached 10, there is no demand, but hot water side, hot water is required. Now how to make the system run? So in such cases, from water to water, it will have to switch to air to water automatically using a hybrid system design. That is possible, and in my opinion, almost all the water to water heat pumps will have to be a hybrid heat pump to make this really work. Okay, now let me move to the comfort air conditioning requirement of chilled water. Many of the big large industries, factories, they do have a chiller plant to take care of thermal conditioning, the normal HVAC design. So here what happens, there will be using a big chiller plant, could be depending on the requirement, office size and all that, maybe a 50 ton, 100 ton, 150 ton plant. So many a times I actually want to narrate one instance where the client has a chiller plant. So he said, give me a water to water heat pump. Looking at the product catalog, talking to the OEM, he bought the water to water heat pump installed. One thing both of them missed was, during winter time, the chiller plant is as good as shut, right? Because nobody requires air conditioning to run during winter, and these are particularly in the northern part of the country. It's very cold, 5 degree, 4 degree and all. Nobody will be really running the chiller plant. Being an industry, they won't generate hot water and circulate for thermal comfort conditioning. They will simply switch off the chiller plant, that is enough. Now whenever this goes off, the heat pump also will go off, right? So it is a practical problem. So this is one thing again which reiterates, most of the water to water heat pumps will end up as a hybrid heat pump for it to work year round. Okay, now coming back to chiller plant. The chiller plant will be having a header giving a, let us normal HVAC design we do for 12 degrees centigrade return water to the chiller, 7 degrees supply water for typically AHU kind of applications. So the 12 degree header will be feeding the water to water heat pump evaporator. it will chill the water from 12 to 7, put it back in the supply chilled water header. This is how normally it works. So during summer and all other 8-9 months of the year, this really helps to reduce the chiller plant load. So if it is having a modulating type compressor, a screw compressor or mini centrifugal compressor, automatically it will be running on part load. So the heat pump will help to further reduce the part load, save more energy. And whenever in winter it is totally switched off, that time this will switch to a hybrid mode. But this is something I definitely want all of you to keep in mind. Whenever you are going for a water to water heat pump, most of the time what you require is a hybrid pump. As long as the chilled water demand is there, it will work as a water to water heat pump. Whenever the chilled water demand is not there, we do not know for how long, it will have to switch automatically to a air to water heat pump. Then only you will continue to get hot water output. So we come to the end of this episode. I think whatever we discussed today is of some interest, information to all of you. If you like this video, I request you to share with all your friends who are also icon managers, ESG champions working in other industries. It will definitely help all of us to decarbonize our workplace as much as possible and help the country to work on its path of net zero by 2070. If you like this video, do subscribe. And if you have any questions, comments, suggestions, do post it here. Thank you so much. We will again catch up next fortnight. Thank you.